Hi everyone, in this video we are going to see about the EMF equation of the transformer. We know that transformers have the primary winding and the secondary winding. So it is considered as the number of turns in the primary winding is N1 and the number of turns in the secondary winding is N2. Phi m, that is maximum flux in the core in Weber, which is equal to Bm into A. F is given as frequency of the AC supply in Hertz. As shown in the figure, the flux rises sinusoidally to its maximum value phi m from 0. It reaches the maximum value in 1/4 of the cycle, that is t by 4 seconds, where t is the time period of the sine wave of the supply frequency, which is equal to 1 by f. Therefore, average rate of change of flux is equal to phi m divided by t by 4, which is given as phi m divided by 1 by 4 into f. Therefore, average rate of change of flux is given as 4f into phi m in Weber per seconds. Now, the induced EMF per turn before is equal to rate of change of flux per turn. Therefore, average EMF per turn is equal to 4f into phi m in volts. Now, we already know that form factor is equal to RMS value divided by the average value. So, to determine the average, determine the RMS value of EMF per turn is equal to form factor into average EMF per turn. As the flux phi varies sinusoidally, form factor of the sine wave is 1.11. Therefore, the RMS value of EMF per turn is equal to 1.11 into the average value. We already determined that average EMF per turn is 4 into f into phi m, which is 4.44 f into phi m. So, the RMS value of the induced EMF in primary winding E1 is equal to RMS value of EMF per turn into number of turns in the primary winding. So, the equation is written as E1 is equal to 4.44 f into N1 into phi m. The phi m is already, we know that Bm into A. So, the equation can be rewritten as E1 is equal to 4.44 f N1 Bm into A. Similarly, the RMS value of induced EMF in the secondary winding E2 can be written as E2 is equal to 4.44 f N2 Bm into A. From the equations 1 and 2, we written as E1 by N1, which is equal to E2 by N2 is equal to 4.44 f into phi m. This is called as the EMF equation of the transformer, which shows EMF per number of turns is same for both primary and the secondary winding. In case of ideal transformer on no load, E1 is equal to V1 and E2 is equal to V2, where V1 is equal to supply voltage of the primary winding and V2 is equal to the terminal voltage of the secondary winding. Next, we will see the voltage transformation ratio. As derived from the above equation, E1 by N1 is equal to E2 by N2 is equal to K, where K is the constant value which is known as the voltage transformation ratio. If N2 is greater than N1, that is K will be greater than 1, then the transformer is called as step-up transformer. If the value N2 is less than N1, that is K less than 1, then the transformer is called as step down transformer. Again, for the ideal transformer, input VA is equal to output VA. So V1 into I1 is equal to V2 into I2, or I2 by I1 is equal to V1 by V2 is equal to 1 by K. Thank you.